Oh. Okay, so what was the solution? Yeah, the solution is this one. So I put BIP with BOP because BOP will trace BIP, so differential input will be small, still small. Okay, and then I put BIM with BOM because those two voltages will track each other. So how can I add them together? So my BIP must be connected like that, right? So those two inputs must be connected together. So I want to calculate I5, I6. Then my differential output was minus I5, I6 times RO. Okay, in the previous case. Okay, let's try to look at this one. So here, this is if this is I1, I2, I3, I4. It is I3. I put this is I3. This is I4. Okay. So I5, I6 is I5 is only I1 plus I3, right? This is I2 plus I4. Okay, then I can write it I1 minus I2 minus plus, is it plus? I3 minus I4. Is it I3? Yeah. Okay. Then let me rewrite it. What's I1 minus I2? Yeah, half GM. VIP, VOP. What's I3 minus I4? Yeah, that's half GM. VOM minus VIM. Okay. Let's see. Is it working fine? Oh, I still got some problem. Do I have a problem for this? VOP. Okay, let's check the circuit. Looks like I got some polarity problem in the original circuit. Okay, here's if this is positive, should be negative there, right? This common gate transistor, the voltage gain is negative. Oh yeah, then this should be positive, okay? So it's fine. This IP is good here. This is a positive input because it just reduces minus output. Okay, so here see this IP is good. And then, so I want to replace this thing by VOP. I just connect this node to there, okay? Then how about the other node here? The other node there is, I have current source there. Okay, so for the D1, this is D2. Yeah, for the D1, let's see, I have to compete with, this should be VOP, right? Is this VOP? Nope. So I need a VOM or something, right? So where is my VIP place? Yeah, this should be BIM, is it right? Yeah, tell me if I am wrong. So this place should be BOM. Is it fine? Until now? Okay. So then, let's just see. This is I1 minus I2. Okay, I1 minus I2 equal half GM VIP minus VOP. Okay. Yeah, so this I1 is added to I3. So I3 minus I4 is half GM VOM minus VIM. So, yeah, so here the current, those two current, sum of I1, I3 flows there. It will flow here, okay? It will flow here. Okay, how about here? Here, I2 plus I2 plus I4 flows there. So if I have arrow there, then see by VOP, this is VOP minus VOM should be negative, right? Negative I2 plus I4, and then this should be positive I1 plus I3 times arrow, okay? How come I don't have a good polarity? Let's replace this one. This is it? This is negative. How come? This is sorry. I need this parenthesis, right? This disappeared already. So is it then correct? I1 minus I2. I1 minus I2. I1. Oh yeah, looks like this is fine now. Okay, let's continue. So my VOP minus VOM is I1 minus I2. What's I1 minus I2? Oh yeah, there. Half GM VIP minus VOP. That's I1 minus I2. And then I must add that I3 minus I4. Half GM VOM minus VIM times arrow, okay? Then I have a VOP minus VOM here and also there. Here, okay? Then see, I can derive VOP minus VOM equal half GM arrow plus 1 times VIP minus VIM. So it still works fine, right? Okay? Question? No? So here, see, because those two voltages, minus input, minus output, they track each other. So differential input is very small here. So I can still use a very narrow linear range differential pair there, right? Okay? Yeah, this is Mr. Zhang's solution. I like it. So here, see, we have a pretty good result. See here, see, this one is my BIP, yellow one is VOP, and then this blue one is VIM, red one is VOM. Yeah, this is from 0 to 3.3. They track each other pretty good, except those some strange places. This is no good. Other than that, we have a very wide input range, right? We can still use this much range, this pretty wide range. Question? No? Yeah, this is ideal CMFB. I just put different combination, okay, in a differential pair. With switch capacitor filter, I got some problem. See, this is input, this is output. I have some, this is CMFB voltage. I have some shift here, right? My output voltage increased a little bit. I suspect it may be charge injection problem of a switch. Okay. Yeah, let's look at the Mr. Zhang's homework. Where is it? Oh yeah, here. Okay. Is it fine? I think, yeah, he used that combination, right? In P, out P combination. In M, out M combination for the differential pairs. So what's this? Slew rate. Looks fine, right? Slew rate. What's the range? Looks like this is a switched capacitor. Actually, he didn't show the full curve, DC transfer curve yet. Okay. Yeah, slew rate reduced with the increase of load cap. Settling time is increased with the CA. Okay. Any question? No question? Okay. Okay.